Hello everyone, and welcome to section 12.3, which is trig functions of general angles. So we'll be given a point, perhaps, that we'll be able to locate in the coordinate plane, and then be able to find the sine, cosine, tangent, and then therefore also the cosecant, secant, and cotangent at that point. Now we can reference a right triangle, so long as we're not talking about the quadrantal angles that we'll be looking at in a little bit. And essentially what we're looking at, when we are drawing our angle, we're always going to be drawing it with the x-axis. And so if I drew a right triangle, and say my point was right here, this seeming random point of root 3 over 2, 1/2, this is actually going to correspond with something in our unit circle. So if I was just looking at this triangle in general and thinking about things in terms of just x, y, and r, sine, I know, is opposite of hypotenuse, so opposite my angle is y. My hypotenuse, since my right angle would be there, would be my radius. Therefore my cosecant, I flip it. For my cosine, I know that is my adjacent over at my hypotenuse. My adjacent for this angle, which is formed with the x-axis, is x, and my hypotenuse is r. Therefore my secant is r over x. My tangent is opposite over adjacent, so opposite y over adjacent x. And for cotangent we flip. Now you pretty much have two choices. You can either memorize this, which you will have to for the quadrantal angles, or if you're given just a random point, such as the one we're about to look at, you can recreate it by drawing a triangle. So, say we are given the point -12, 5. If I draw -12, 5 on my coordinate plane, it's around there. This is my official angle, however, I am forming things with my x-axis, so this is the triangle I'm looking at. My y value is 5. My x value is -12. And my radius I will find by using the Pythagorean theorem, or recognizing my triple. So I see that I have 5, 12, 13, or I can do 5 squared plus 12 squared equals 13 squared. Notice how my x value is negative, therefore I do have a sort of negative side with my triangle, but we're not actually constructing a physical triangle, so that's okay. So sine, opposite over hypotenuse, so sine of my theta is 5 over 13. I will utilize the negative portion for my actual values. Cosine, adjacent over hypotenuse, tangent, opposite or y over x, and then for my cosecant, secant, and cotangent, I just flip all of those. That's how we can find all of our trig functions just based off any given point that they give us. You can recreate the triangle, you can draw it out for yourself, or simply use these ratios that come from if we were to draw the triangle out. Now, there are some angles that occur on what we call the quadrants. So right between the first and second quadrant, right between the second and third quadrant, right between the third and fourth, and right between the fourth and first. These we are not able to draw the triangle, but we can still use the same ratios with the x, y, and the r. So 0 is my x, -2 is my y. To find my radius, I'll do Pythagorean theorem. So 0 squared plus -2 squared equals c squared, which is actually r in our case. So 0 plus 4 equals c squared. 4 equals c squared. And c, or our radius, must equal 2. So, I know that sine is y over r. My y value is negative 2. My r value is 2. I can simplify that to negative 1. For my cosecant, I'm just flipping this. Negative 1 over 1 is still going to give me negative 1. Let's look at our cosine. From our ratios from above, we know that cosine is x over r. My x value is 0. My radius value is 2. 0 divided by 2 is equal to 0. My secant, I flip this fraction. So I've got 2 over 0, which is undefined. For my tangent, that's y over x. My y value is negative 2. My x value is 0. That's undefined. And then my cotangent, if I flip this, 0 over negative 2, I get 0. There will always be this dynamic of some of these are zeros, there are 2 undefineds, and then the other 2 will either be 1 or negative 1 on our quadrantal angles. So that will always exist. We have this thing called reference angles. So reference angles are in relation to that x-axis again, and we're pretty much just looking for what angle we form with the x-axis. If we are an angle in the second quadrant, essentially what we're doing is we're looking to see, okay, well, how much more would I have to get to that 180 or to that pi? You can use these formulas or think about it as how much more you have to get to that 180 or to get to that pi. So for example, if I had like 150 degrees that is in the second quadrant, it's more than 90, less than 180, how much more would I need to get to that 180? I would need 30. In quadrant 3, we have passed the 180. We still want to be in reference to that x-axis though. So I'm looking at how much past 180 I am. So say I had 200. My reference angle, that is 20 past 180. And then if I'm in the fourth quadrant, I'm not quite at that 360, but I am past the 270. So I'm not going to be looking back at the 180, I'm going to be looking back up at the 360. So I'm going to take my 360 and subtract however much I have for my angle. So say I had 320. My reference angle, how much more to get to the 360 would be 40. We can do the same thing with the pi's, with our radians, but with those it's actually going to be a little bit easier because you can sort of look at the denominator. And I'll show you what I mean. So find our reference angle for 330. If you need to draw it for yourself, that's fine. You're always going to be referencing the idea of the 0, the 90, the 180, the 270, and then the 0 also corresponds to 360. That is between 270 and 360. So I'm looking to see, okay, how much more do I need to get to that 360? So my reference angle is 30 degrees. Because 30 plus 330 gets me to that 360. Find the reference angle for negative 5 pi over 6. So this has two things going on. Not only is it in radians, but it's also negative. So I have to make sure I'm thinking of the opposite direction. I've got pi on one end, 0 and 2 pi on the other, pi over 2, and 3 pi over 2. Negative 5 pi over 6, if I ignore the pi for just a moment, That's almost -1. So we're almost at -pi. We're going to be in this quadrant. How much more do I need to get to that -pi? Well, I've got a denominator of 6, and I had a pi. My reference angle is going to be pi over 6. My reference angles always have to be two things: positive and acute. Pi over 6 corresponds to a 30-degree angle, so it is both positive and it is acute. The fact that my initial angle was negative made no difference for my reference angle. It's still going to be that positive angle value for the reference angle. And we'll have plenty of practice with this. The last thing that I'm actually not going to talk about right now, but rather save for class, because I have sort of a trick to kind of help you remember all of this stuff. If you're more of a memorizer person, if you really like flashcards, this is a great thing that you can make flashcards with. I would say do it with the degrees, but also the radians. Partial trick with our radians is you can tell by the denominator what your reference angle is going to be. If you have a 4 in the denominator for your radians, your reference angle is always going to be a 45. If you have a 3 in your denominator for radians, your reference angle is always going to be a 60. And if you have a 6 in your denominator, your reference angle is always going to be a 30. This, paired with the trig hand jive that we'll do in class, and a simplified version of this stuff, is going to be the key and most simplest way that you can kind of get all of the information down without having to memorize a whole lot. So we'll do the trig hand jive in class. I would recommend that you download the trig hand jive off our class site at this time, or at least sometime before class, and I will see you then.